Hello and good morning to everyone. So our today's lead code question is 1461, in which the title is check if a string contains all binary codes of size k. So in this question we are given a string s and an integer k, and we have to return true if every binary code of length k is a substring of s. Otherwise we have to return false. So let's see this example. So k is equal to 2. So what are the all the binary codes? So 0001, 10 and 11. These are the four different binary codes. So what we do is I will check all the substrings. So of size k equal to 2. So 0001, 11, 10. So if you have noticed, all the four substrings are equal to the binary codes. So for this we will be returning true. Let's see the next example. So in the next example we are given 0 1 1 0 and k is equal to 1. So k is equal to 1 means 0 and 1. So 0 and 1. So we get the answer. So we return true. Again k is equal to 2. Again we have to find 0 0 0 1 1 0 and 1 1. So let's see, check the all the substrings. So all the substrings are 0 1 1 1 and 1 0, right? But one uh, 0 0 is not present. 0 0 is not present, so we return false. If you see the constraints, the string length can be up to 5 into 10 ki power 5. So we can go with the solution of n log n or big O of n, right? And s of I either 0 or 1, and k is up to 20 only. So first approach that hit to my mind was we can use sliding window to find all the substrings, and then we store all the substrings in the set, in a set, because set store only unique values. So even if a substring repeats, set will store it only one times. So for length k, what are the total binary codes are 2 ki power k, right? So if k is equal to suppose 2, total codes is 2 ki power 2, that is 4. So if for a length k, total codes are 2 ki power k. So now what we have to do is we have to find exactly 2 ki power k unique strings, 2 ki power k unique substrings of length k, right? This is what we have to find. So suppose if string length is n, length of string is n, and so what will the number of the windows of size k? So the number of windows of size k is n minus k plus 1, right? So if the number of sizes or number of windows, this n minus k plus 1, is less than 2 ki power k, then we have to return false, because we need 2 ki power k uh, unique substrings, right? 2 ki power k unique substrings. But if the windows are lesser than 2 ki power k, then we'll directly return false, as then it is impossible to contain all the binary codes. And if this condition suppose fails, then what we do is we'll find all the substrings using sliding window. So we slide a window of size k from left to right, and for each position what we do is we will find the substring s, that is from I to I plus k minus 1, using the function substr. In that we pass the index and then the length k, right? And then we get the substring, we insert this substring into the set, and at the end what we do is we'll check if the size of the set is 2 ki power k. If the size of set is 2 ki power k, that means we got 2 ki power k unique substrings, and the number of our binary codes is also 2 ki power k. So in that case we'll be returning true, as we return false. So let's see an example to get it more clearly. So here we are given the string 00110110 and k is equal to 2. So what are the possible windows? 00011110 01 again, 1110. So these are the possible windows. So we'll store all these windows in the set. So what will be the unique values in the set? 00, 01, 11, 10. So these are repeating. 01 is repeating, 11 is repeating, 10 is repeating, and we know set store only unique values. So see, the size of set is 4. So is it equal to 2 ki power k? So our k is 2. So 2 ki power 2 is also 4. Means we get our all unique binary code. So we'll return true. So if you'll see the complexity of this approach, so for from every index I, we are finding a substring of size k, so it will take big of k, and this we are doing for n minus k plus 1 windows. So the time complexity is n minus k plus 1 into k, so we can write is big of n into k, right? And the space complexity is big of 2 ki power k, as we are storing 2 ki power k unique substrings in the set. So let's see the code. So what initially, like we have taken length of the string, and if k is greater than the length of the string, then we directly return false. And then we have stored a variable need, which is how many so see, one right shift k is equal to 2 ki power k. So need has stored how many unique binary codes we require. So we require 2 ki power k unique binary codes. So this is one left shift k. One left shift k is equal to 2 ki power k, means you will shift the uh, bit 1 k times, right? And then the number of window sizes is n minus k plus 1. If that is less than need, or that is less than 2 ki power k, then also we return false, because if each even if each window gets us a unique value or unique binary code, then that is less than our need, so we return false. And then what we do is we make a set of string seen, an ordered set, right, to store all the unique substrings. Then we go to each index, find the substring on that index of length k, and store that in the set. And at the end, and if seen dot size, means if the number of substrings in the uh, set is equal to our need, then we return true directly. This is to early exit, means instead of checking all the substrings, we stop whenever we get 2 ki power k substrings. And at the end, after the loop, we again check the size, and if the size is equal to the number need is 2 ki power k, then also we return true. Else if the condition is not satisfied, it automatically returns false. So the time complexity here is big of nk. So let's optimize this. So in approach 2, which is optimized approach of the previous one, what we do is, so in previous approach we were storing strings in the set. So in this approach, what we do is, instead of storing strings, we convert each substring into a number. So see, 101 is there now. So we store 5 instead of storing 101, we store 5. So we convert binary substring into binary number, and we store numbers from 0 to 2 ki power k minus 1, right? If k is there, then what is the maximum number? Maximum number is 2 ki power k minus 1. So we store all the number from 0 to 2 ki power k minus 1. So let's see step by step what will be the approach. So first, step 1, convert the first window to a number. So see, we are given a string s and k is equal to 3. So what will be the our first window? First window is 001. 001. So what is a, this is binary, so in decimal it is 1, right? When we convert it to integer, it is 1, right? And then what we do is we store this one in a vector. Let's suppose we make a vector scene. So scene of 1 is equal to 1, means we have already get 1 at some point, right? And then step 2, that is a rolling trick. So suppose our current number is x, here our x is 001, right? That is the value of the last k bits. So when we move ahead, what we do is we shift x, we shift left x by 1. So our x was 001. So when we shift x left, it will become 0010. Then what we do is we remove the leftmost bit. So if we remove leftmost bit, this one, then our x will become 010, and then we add the new bit. So what is our new bit? New bit is 1. So if we add the new bit in this x, then it will become 011. So is that the new window? Yes, 011 is the new window. So with this rolling trick we get our new window. So what we are doing is, first we are shifting x leftwards by 1 bit, and then remove the leftmost bit, and then add the new bit. So how will be removing the leftmost bit? So for removing the leftmost bit, we are using a mask, right? So how to create the mask? So we are given k. So the maximum value that we can get from k is 2 to the power k minus 1, right? So we'll be using that, the binary value of this, as the mask. Suppose our k is equal to 3. So the mask is 1 left shift by 3 minus 1, that is 8 minus 1, yani 7, that is 111. So this is our mask. So what will be our update formula? So what we do is, first we left shift x by 1, shift left x by 1 bit, and then AND with mask, and the overall answer we OR with the new bit, right? So let's see with an example. So suppose this is our string 10110. So what is our first window? 101. So our x is 101. Now we left shift it by 1 bit, so it will become 1010. Then, and here k is equal to 3, so our mask will be 111. So after shifting we end with mask. So 1010 and with 111, so we get 010. Then the third step is we OR with the new element is 1. So 010, sorry, OR with new element, so we get 011. So is that our new window? Yes, that's our new window. So now our x is 011, and the next new bit is 0. So again we do the same thing, left shift by 1 bit, so it will become 0110. Then AND with mask, that is 111, so we get 110. Then OR with the new bit, so OR with 0, so 110 only, and that's the our final window, right? I hope you get the steps clearly. So what will be the complexity of this approach? So earlier our complexity was big of n into k, but now the time complexity is big of n. So it is faster than the previous approach. And if you see the space complexity, it's still the same. So let's see the code of this approach. So first is like the same condition. If k is greater than the size of the strings, then we return false. Then we find how many unique codes we need. So we need 2 to the power k codes, and if the number of windows is less than unique codes, then we return false. After that we have used a vector in which we will be storing all the numbers that we have seen, and int goat, it will store the count of unique numbers that we have got up to now, because the count of the unique number should be 2 to the power k. If goat is equal to 2 to the power k, then we return true, else we return false. And we make our mask is equal to 2 to the power k minus 1, that is need is 2 to the power k, so need minus 1, and int x is equal to 0. Then we are building our first window. So for building our first window, what we are doing is So x is equal to 0 initially, and suppose k is equal to 3, and our string is 101110. Let's say this is our string. So we shift x by 1, so it will become 0 0. Then what we do is we OR with the first element, we OR with 1, so it will become 0 1, right? Then again we do the same thing, shifted and OR with 0, so it will become 1 0. Again the same thing, OR with 1, so it will become 1 0 1, right? So we get our first window, and so after getting our first window we mark our first window in this vector as true, that we have already seen this binary or seen this x, and we increase our count by 1. Then we follow the steps of roll. So in roll what we were doing is we were first left shifting by 1, then and with mask, and then or with new. So see, shifting x by 1 bit, then and with mask, and then or with the new bit, right? And if we haven't seen this x previously, that is if not of scene of x is true, means scene of x is false, we haven't seen it previously, then we mark it as seen and we increase the count. And if the count is equal to our requirement, that is 2 ki power k, then we return true, right? And once suppose our loop is completed and this condition is not fulfilled in between somewhere, then we check at the end whether the number of unique numbers that we get is equal to need. If the condition is satisfied, it will return true, else it will return false. So I hope I am able to explain you both the approaches clearly. So if you like the solution, please make sure to like, share and subscribe the channel. Thank you.